today we'll be solving absolute value equations and inequalities. So we'll be looking at three types. First will be an absolute value equation. The second will be an inequality, an absolute value inequality with a less than or less than an equal to sign. And the third type will be an absolute value inequality with a greater or greater than or equal to sign. So before we get started, let's look at what our solutions will look like. For an equation, we'll end up with an or statement or two solutions, and sometimes there'll be no solution. For less than or less than and equal to, we'll end up with an and statement, a compound inequality and statement, and sometimes there'll be no solution. And when we solve the greater than or greater than and equal to, we'll end up with an or statement, and sometimes the solution will be all real numbers. So let's start with the procedure on how to solve absolute value equations. Step one is always to isolate the absolute value. Step two is to remove the absolute value bars. And step three, we're going to write two equations. The absolute value is going to be equal to a positive number, or the absolute value is going to be equal to a negative number. So number two, the absolute value of p is equal to 9. First, we want to ensure that we've isolated the absolute value. And we have. When we isolate an absolute value, that means it's all by itself. There's no numbers being added or subtracted, multiplied or divided outside the absolute value bars. So this is isolated. We're going to remove the bars and write two equations. One with whatever's inside the absolute value equal to the number, or the absolute value equal to the negative, the opposite of this number. So p is equal to 9, or p is equal to negative 9. And those are our solutions. Number 3, the absolute value of 6n plus 7 is equal to 23. Step 1, isolate the absolute value. It is. Step 2, remove the bars. Write two equations, one equal to the positive 23 and one equal to negative 23. And go ahead and solve. Number 4, 4 times the absolute value of n is equal to 40. We need to isolate the absolute value. It's being multiplied, so we're going to divide. We're never going to distribute. We're always going to divide to undo the multiplication. Now go ahead and solve. Number 5, the absolute value of x minus 6 divided by 3 is equal to 4. So isolate the absolute value, remove the bars, write two equations, and solve. All right, try number 6. Try number 7. So now let's look when there's no solution or the special cases for equations. Absolute value equations cannot be solved if the absolute value is isolated and the absolute value then is equal to a negative number. So we know when we take an absolute value of any number, it's a positive number. And since no positive number is equal to a negative number, there's no solution. So number 9 is an example of this. We have an isolated absolute value equation that's equal to a negative number. So there's no solution. So go ahead with number 10. Isolate the absolute value and then determine whether there's a solution or not. All right, let's solve absolute value inequalities. Was less than or less than and equal to? When we think of less than, think of the word and. We'll be writing an and inequality. So again, to begin with, we'll always isolate the absolute value. We'll remove the absolute value bars. And we'll write a compound inequality. We'll write this and statement. So here we have the absolute value of r is less than or equal to 9. And our absolute value is isolated, so we're going to remove the bars and write a compound inequality. So we're going to take this number, whatever it is, this positive number, and make it negative. And that negative number is going to be less than or equal to whatever's in the absolute value and less than or equal to the number we have. So in this case, I made a graph just to show you any number between and including negative 9 and 9, r can be any of those numbers. So go ahead and try 13. Okay, try 14. Okay, try 15. All right, let's look at the cases where there's no solution for the less than. Absolute value less than inequalities cannot be solved if the absolute value is isolated, and then the absolute value is less than a negative number. Remember, an absolute value of any number is positive, and a positive number is never less than a negative number. So here we have an example of that. We have an isolated absolute value that's less than a negative number. Since this is positive, no number is less than a negative number, so there's no solution. Now on 18, we do have this absolute value inequality equal to negative 22, but we can't determine whether there's no solution or not until we isolate the absolute value. So go ahead and do that. And now we'll look at the absolute value inequalities with the greater, and we're going to think of or. Greater, we're going to be writing an or statement. So again, we're going to begin by isolating the absolute value. Then we're going to remove the absolute value bars. And then we're going to write a compound inequality. The absolute value, the numbers inside the absolute value, will be greater than n, or the absolute value will be less than negative n. So here we have the absolute value of x is greater than 9. Our absolute value is isolated. That's going to give me a positive number that's greater than 9. So we're going to remove the bars. So our solution is x is greater than 9 or x is less than negative 9. Make sure you flip your symbol on these. So go ahead and try number 21. Try 22. Try number 23. Try 24. Try 25. So let's look at the special cases for the greater than or statements. The absolute value for greater inequalities solutions is all real numbers when the absolute value is isolated and the absolute value is greater than a negative number. Remember, the absolute value is a positive number, and all positive numbers are greater than a negative number. So 27 and 28 are examples of those. And here's a summary when solving absolute value equations and inequalities. You're always going to begin by isolating the absolute value. Then you're going to look for a special case. You're going to see, once it's isolated, is it equal to, less than, or greater than a negative number? If it's equal to or less than, there's no solution. If it's greater than a negative number, it's all real numbers. So if it's not a special case, then you're going to solve. So if it's a positive number, you're going to remove the bars and write two equations or inequalities.